Now let's wire up the ASP.NET Core API to work with the author data. There will be a bunch of steps to follow, but we'll start by creating a set of API endpoints to interact with authors by way of the pub context. Instead of just a single endpoint like we have for reading weather forecasts, these will be multiple endpoints to read, add, update, and delete authors. And that means the new project needs a reference to the domain project and the data project. Once we've done that, we can go ahead and add the new endpoints. And you can do this pretty easily in Visual Studio by right-clicking the project folder, then Add, and then choose New Scaffolded Item. And from there, you can filter down on APIs, and you'll see a list of API options. Choose the one that's on the bottom, at least that's where it is here, and that's API with read-write endpoints using Entity Framework. You'll be presented with a few options for how the controller can be structured. As part of the workflow, Visual Studio now asks us to identify which model and which DB context class to use. I have my environment fonts larger than normal for recording these demos, and unfortunately this form doesn't play well with that. But it's the word class that's chopped off on these options. So first we choose the model class, which is author, and next is the endpoints class. The endpoints code doesn't belong in any of our existing classes. There's going to be a lot of code. So click the plus sign to create a new one, and the template will default to naming the new file author endpoints, which works for me. So I'll click Add, and finally I'll choose the pub context for the DB context class. Notice that when I choose that, the next field for the database is grayed out and says configured from the selected DB context. We will be changing that, but it's okay for now. And I'm also leaving the checkboxes in their default mode, which is checked. And I just want to point out what this OpenAPI checkbox is for. OpenAPI is what enables ASP.NET Core to work with the minimal API endpoints. Finally, I'll click Add, and the scaffolding logic gets the required NuGet packages and other dependencies. Then it rebuilds the project and generates the endpoint code. Let's take a look at what happened to the CS.proj file. Some new packages have been added. There's a package reference for an ASP.NET Core Entity Framework adapter and one for OpenAPI. Then there's the tools package in case I want to run any more migrations. And remember, I had that in the console project in the other solutions. The code generation package was used by the project to build the code for the controller, and Swashbuckle is the API that makes Swagger work, and that was already there. And there's the project references. Those got added when I referenced the projects earlier. There is one change I do want to make here, though. I want .NET Core packages to keep up with minor releases. So instead of 8.0.0, I will change them all to 8.0. All of the logic in the endpoints class is wrapped in this method called addAuthorEndpoints. And key is one line of code that's been added into the program.cs class that calls this method. It's all the way down here right before the call to app.run, and it's app.mapAuthorEndpoints. That was also added as part of the code generation, and it's how the program is aware of all the endpoints in the new class. I'll scroll through the author endpoints class quickly, and we'll learn more details about what these methods do while we're debugging them, and then further on when we're doing some of the refactoring. I want to forewarn you that while the template-generated code is a stake in the ground, it reflects a bit of an anti-pattern by sending the domain objects retrieved using EF Core back to the caller. But for now, we'll work with the controller as is, just enough to get it running, and then I'll show you how to do a small refactor that will make the controller work more closely to how most ASP.NET developers prefer to use it. The code generator created 5 endpoints, and each is configured with a map method like you saw with the weather forecast. First is a mapget that will return all of the authors using a passed-in instance of the pub context. There are 3 things I want to point out about this code. First is that it's literally getting every author in the database. And that's fine with our demo data because I only have about 15 authors. But in a real application, I would be very wary of exposing an endpoint where it's that easy to return a ridiculous number of results, unless you have a very good reason. The next thing I want to point out is that it's using async versions of the link execution methods. That's standard practice for web apps, so you don't hold the user interface captive and your users twiddling their thumbs or just heading to another website while waiting for results to come back. And finally, we know that we don't need to change track these results, and that could be a costly waste of time and resources. This query should be using as no tracking. I'll add that in, but shortly I'll also show you another way to get around that in case as no tracking is forgotten. Next is the mapping to get an author by ID, which expects an integer ID passed in along with a context instance. This time, the method does use as no tracking to find the correct author with the first or default async method. Next is a put mapping for updating author data, and you can see it's using the execute update async method. This is a great use for those direct execution methods. It's much more efficient. Otherwise, we'd have to start tracking the author with the update method, which would engage the change tracker and use more resources. And it also means there's no need to call save changes, which is what we do have to do in the next method. The post used for adding a new author. This one calls add and save changes. And finally, the map delete. All that one needs is the ID of the author to be deleted. And this one calls execute delete async to get the job done quickly and efficiently. I love seeing how the execute update and execute delete methods really pay off in disconnected apps. Unfortunately, in the version I'm using, there is a problem with the generated code, and it's already in for a fix on GitHub, so you may not even have this problem. While the CodeGen recognized that my key property is named author ID, and you can see that here in the parameters and here in the query string is just ID, and that will cause the API to throw an exception. It needs to match the name of the variable that's used over here in the parameter, which is author ID. So I'll change it to author ID. And we've got the same problem in the put and delete methods, so I'll make that change there as well. With the controller added to the ASP.NET Core app, it's time to wire up the ASP.NET Core app with a DB context. We need to let it know about the DB context, and that's done by configuring services in the program class. ASP.NET Core uses dependency injection, often referred to as DI, to interact with other features, including EF Core. The dependency injection is managed through ASP.NET Core's services, and we create a different service to manage each of these different features we want the application to interact with. If you're new to dependency injection, don't worry. ASP.NET Core will take care of the hard part. You just have to connect a few dots, which is what we're doing here. And hopefully, after this explanation, you'll have a better understanding of it. There's a whole course on dependency injection in C# by Henry Bean, which I'll link to in the resources slide for this module. We'll add a service to manage the pub context, which is easy thanks to an extension method provided by Entity Framework. I'll start with the Builder Services collection, following the examples already in the class, and then add DB context. That's the extension method. And the method is generic, so we then have to say that it's for the pub context class in the publisher data namespace. The add DB context method expects a lambda to describe the DB context options. So in the parameter, I'll name the lambda variable opt, OPT. Then there's the lambda operator, and now the opt variable lets me apply some methods. We've seen DB context options before. That's how we configured the database provider, the connection string, and more in the DB context. But all of that's going to happen in the program file now because the service will be responsible for instantiating the DB context for us. Just like we did with the options in the context file, I first need the use SQL Server method. Then I need the connection string, and I'm sticking a placeholder there for the connection string. I also want to enable sensitive data in the logging. But notice I'm not going to add the logging method that we used earlier because logging is built into ASP.NET Core, so that's helpful. There's one last thing I'll do here. Remember, the DB context options has a method called use query tracking behavior. So I'll just define no tracking for this context right here in the service. That means the context used by the API we'll never track any query results. And that also means we don't have to worry about whether or not the code generator adds as no tracking to queries, or if the developers forget to do that. Rather than hard-coding the connection string, I'll put it into the app settings file. And at the same time, I'm going to specify the EF Core logging information that I want to be output. This is a JSON format file, and it already has some default configuration set up for logging. So I've just added in a section for connection string with one named pub connection, and its value is the same connection string we've been using all along for the pub database. But I also added something to the logging section. Does it look familiar? It's the same setup we used earlier, but expressed in a much easier way as a configuration. I've specified that along with the default logging information, the logs should also output the SQL commands generated by EF Core, and the log level, like before, should just be information. What I'm not telling it here is where to output the logs. By default, ASP.NET Core is set up to output to console, debug, and a few other places. So I'll show you two ways you can see the logs when it's time to debug. But we still have a few more steps to do this wiring up. And the very next one is that I need to return to the program class and replace my connection string placeholder so that it can find the connection string I just added into the app settings file. And I've done that by saying to read the builder configuration. Then configuration has a get connection string method. And as its parameter, I've passed in the name of the string that I defined, which is pub connection. If this is the first time you've done this wiring up between ASP.NET Core and EF Core, it may seem like a lot of steps. But once you've done it a few times, it just feels routine. So I hope you'll trust me on that. And the bad news is we're still not quite done yet. The last stop is in the pub context file. We're going to add a constructor that can work with the dependency injection that we just defined in the program class. And then we'll just do a little cleanup. First, I should probably show you why we need another constructor in the DB context. Each endpoint method expects a pub context instance to be passed in. The author endpoints class is static, though, and it doesn't even have a constructor, so it's not responsible for making sure there's a pub context instance available. And that's because it's using a software concept called loose coupling to make sure your software is more flexible. You can learn more about loose coupling in Steve Smith's Solid Principles for C# Developers course, but it means that whatever executes these endpoints needs to instantiate the pub context first, and this is where the dependency injection kicks in. What we did when defining that service in the program class was tell the ASP.NET Core app, hey, anytime you find a constructor that expects an instance of pub context but you don't have one, go ahead and create it on the fly and use these options. There's only one problem. The pub context doesn't have a constructor that takes in the DB context options, and that's what we'll create now. I've added this new constructor into the pub context that's defined to accept and use the DB context options. First, by specifying that it should take in a parameter, and the parameter is a DB context options of pub context. I'll give it the variable name options. The internal DB context class already has a constructor like this, so I'll add here that it should do with options whatever the base class's matching constructor already knows how to do with the options. Now the ASP.NET Core app will be able to instantiate a pub context, pass in the options we defined in startup, then pass the resulting object into each of the map-get methods. So the last little bit of work here is to do my favorite type of coding, which is to delete code. Since all of the context configuration information is now specified in the startup file and the app settings, and the logging is built into ASP.NET Core, I can remove the entire onConfiguring method, and then you can also clean up the using statements that aren't needed any longer. So that's it. Finally, the ASP.NET Core app now knows how to work with the pub context and the pub database, as well as include the SQL commands in the logs. And we have API endpoints that will let us use EF Core and the context to interact with author objects.